So hi everyone, I'm Tal. I'll stand here. I'm Tal from Arato. We were introduced. Thanks for the introduction. And today I'm going to talk about a layered approach for evaluating agents. Before I start, just to map out the crowd, let's run our first evaluation for the day. How many people here run production agents in production? Okay, nice. And these are all, and how many of these are completely autonomous, making decisions on critical business decisions? Okay, they're a little bit less. Okay, cool. So I'll start with talking about how we evaluate a single prompt just to align everyone here. Then we'll talk about evaluating multi-step interactions. And finally, we'll get to see how we can approach this complex question of evaluating agents. I think like for those who are already running agents in production know that it's extremely difficult to let them go and trust that they'll do what we want them to do. So let's start with why evals. How many people here are software engineers? Cool, okay. So I think like it's already in the water that when we test, there's some hands there, not for me, okay. So there's some, I think it's already in the water that when we test deterministic code, our tests themselves are also deterministic, right? We have this assumption that when we call a function, it always returns the same value for the same input, right? And our assertions are also deterministic. It's like a math function, f of x equals y. Now with non-deterministic systems, like when we build with LLMs, I think it's useful to think of this more maybe a biology experiment, right? To reach some conclusion about such experiments, we need to test many variations of inputs, collect the data, aggregate it, and then be able to say something smart about, is my system working as I expected or not? And even then, we know it's not going to be 100%. Right? It's going to be good enough for my use case. So what we use evals for is to take a really abstract and complex question of, is my model working, right? Is it operating as I expect? Is my prompt good enough? To something that is more concrete, right? We want to break this question down into the smallest bits possible, ask specific questions. For example, I can ask, is my LLM response time as I expect? Is the output of the LLM, does it stand in some standards that I defined? For example, maybe if I have a prompt that is summarizing something, then I want my evaluation to look at the two sides of the input and the output and say something about them, right? But I want to output very specific metrics. And here are some examples that you've all seen, type of evals like content evals. I want to look at text, maybe do some similarity between different text. I want to look at the format. I want to look at some of the qualities of the text, like the correctness, and some non-functional guardrails like tone of voice, politeness, stuff like that. All of these produce a metric that I can then use to also communicate with my team, right? Because if, let's say, my colleague made some change, and instead of telling them, listen, like the thing is not working as before, I can be much more specific, right? Because when I have these evals and I have these metrics, I can talk about specific qualities of the prompt or of the model, and then we can use that to communicate. We can use it to ensure that we are improving. Maybe I'm using prompt and model interchangeably. When I say prompt, I usually mean the prompt, model, and model configuration, right? This is the thing that we're normally changing. So yeah. So now that we've seen what evals are, again, these are some code that takes an abstract question and breaks it down into a specific question with a specific metric. Let's start looking at how we can evaluate a single prompt. So the first problem we have with prompts and with model is testing for consistency, right? We've seen that, or we know that for the same input, we can get multiple outputs or different outputs every time we run it. And this means that the evals that we created will produce a different output as well. So how can we make sure that we are setting kind of expectations of the qualities or the performance of our system? So to do this, we need a few building blocks. The first one is the prompt template. This is the kind of the business logic that we want to test. In this case, and it comes in different shapes and forms, but normally there is the instruction to the LLM and some placeholders or variables that will be replaced at runtime. The next building block is a dataset, right? The dataset includes specific values that will be replaced at runtime. So if I go back to this, I have translating a word from one language to another. And here I have some examples. And the most importantly, I have this column here with some expected responses or labeled data, it is normally called. And then what my testing platform would normally do is take these values from the dataset, run them through the LLM, and produce some output. And then if you add our evals on top of that, we can start to reason about for which of these lines, of these inputs, did my evals produce an outlier, right? Some outlier values, right? If I run it over and over again, I can start seeing some of the patterns. And then for the values that produce outliers, I probably want to go and see why my prompt is not behaving as expected. So this is just the basics of how we approach testing a single prompt and tune it so that the evals will always produce kind of consistent values, and therefore we can assume that the prompt is, and the model again, are working as expected. So now let's see what happens when we have multiple steps. And I'm going to use this coding assistant chat as an example. And in this case, our data set, before we tested each line separately. In this case, our data set looks more something like this, like a list of threads. Each thread has an input message to the LLM and a response. And there is something new happening here because what we want the LLM to do is not to reply based on just a single row, but we want it to accumulate the context, right? Every time let's say we do the second iteration or the second message to the LLM, we expect it to also use the context of the previous message. So then we have a new problem. And this problem is testing for convergence. If previously we only looked at the consistency of a single prompt, now we also need to test for the convergence of this entire thread. So how can we do that? So we need to develop evals that take a look at multiple steps, multiple steps in the thread, not just across, but also vertically. And if we do something like this, in this case, I use the semantic similarity. For those who don't know, semantic similarity is a way to compare two texts and give some measure on how much they preserve the meaning, even if they use different words. So in this case, we can see that the thread diverges after a few steps. And this is normal, right? Like we can probably never create a data set that will never diverge, but it does give us some information of where are the breaking points, where are the places where our model and our prompt or our system prompt actually is breaking. And we can develop additional such multi-step evaluations. For example, let's say we have a support bot and it is giving replies to our users, to our customers. We want, for example, to have some eval to check that the conversation is not too long, right? So we will we'll develop an eval that looks at the length of a conversation until it gets to some satisfactory answer that we have in our dataset. So what we did is that we showed that we can use the same tools, the same capabilities of taking this complex question and asking more specific questions that will give us specific metrics. In this case, we'll develop these multi-step evals. So we're still in the domain of evals for more complex questions. Next, let's talk about evaluating agents. So what is an agent? Okay, so this is a screenshot of OpenAI's agent builder that they released a couple of weeks ago. And I went to the agent builder, I hit new, and it created a workflow. So is this a workflow? Is this an agent? What is this? I don't know. So let's start with just defining what an agent is. So there isn't an official definition, but I think you can agree that these are at least some of the qualities of an agent. First, it has one or more steps, specifically steps working with or interacting with an LLM. It has something to orchestrate these steps. In this case, we have this workflow deciding what steps should be taken next, and it can use tools. Okay, it can activate tools. Again, not an official definition, but good enough for what we're doing here now. So if we look at an agentic framework architecture, it normally looks something like this. On the left-hand side, I have some common capabilities or functionalities that are provided by the framework. For example, memory management, knowledge management, maybe some MCP service registry that the different agents can use. And I have an orchestration layer. On the right-hand side, I have the actual agents. These are normally the prompts combined with the tools that each prompt can use. And a lot of the work for engineers is actually building the right-hand side. Right? Left-hand side is normally taken care of by the platform, except from where, in the example we saw before, that where the agent orchestrator is not LLM based, it's workflow based, like we saw in the OpenAI example. And then the developer would also need to build the workflow. So previously we saw a linear execution plan, right? We saw a chat that has only a linear plan. Here we start seeing more complex such execution plans. And this actually brings back the question of testing for convergence, which now just becomes much more complex. And the question is, how do we go about it? So I think it's no different than what we do with our normal testing for normal code, for deterministic code. I think we always have this balance of when do we write a unit test versus when do we write an end-to-end test or integration test, right? And I think the majority of times we want to focus on the smaller building blocks, and we only write integration tests for the most critical paths, right, in our software, because there's no way to cover all paths. And the same thing happens here. I think for agents, we need to carefully choose where we're going to develop these multi-step evaluations to help us understand if our agent converges to what we want. But most of the effort will still be on the individual prompt level blocks. And then what about tools? This is also new for agents. And tools are what give agent their superpower, right? This is how we interact with the real world. And I think the nice thing about tools, at least for when it comes to testing, is that normally they are a representation of an API, a deterministic API that is exposed via a tool. And we can use that to our advantage when coming to test how LLMs or our agents interact with tools. So I think the first question is the right tool being called, right? If I give an LLM multiple tools as options, will it choose the correct tool? And this is, again, an eval that we can write, right? So let's look at a simple example. I have a stock quote agent here that will get, you can ignore the system prompt for now, but it will get either a stock quote or ticker, like MSFT, or will get a company name. And I want you to choose the correct tool according to the user input. And I'm defining, I'm not going to go into too much details here about the tool schema, but I'm defining two tools. One is a get stock symbol, and the other one is called get stock quote. Okay? This is, for those who don't know, this is just a way to define tool schema to define tool schemas for the LLM. So I'm going to send this over to the LLM. But going back to my building blocks from before, this is the data set that I have. I have a mixed input data set where I sometimes will give the LLM stock symbol, sometimes I will give it just a random word, and sometimes I will give you a company name. And in my expectation column, I'm setting the tool that I expect it to call. Okay, and then what I can do is I can write an eval to look at the response from the LLM and see if indeed the correct tool was called. We won't get into the actual eval now, but if we look at some responses, sorry, variables, where are you? Oh, there. If we look at the responses, we can start seeing that indeed it called the correct tool for the correct input. In this case, it called get stock quote for MSFT, and it called get stock symbol for Banana Republic, and it did not call any tool in case of just the random text. So again, a simple example of how we can use evals to now test that the agent is actually calling the correct tool. So same building block as we had before. The next problem that we want to handle is how does the tool interpret the LLM response, right? Because the tool response. So let's take another example. We'll do the same thing. This time though, going back to the chat example where we had a context building up. So we have the same system prompt from before, the same problem that we wanted to answer either with, we'll get either a stock quote symbol or a company name as an input. And this time I'm also giving it some mock data of tools that were called and a response that these tools responded with. Okay, so I have this template of a tool call. This time is a get stock symbol and return some value. And if I call the tool get stock quote, I expect it to return the price. And my data set now will include all of these values for these placeholders so my test can run. For example, I have Microsoft here and the symbol and some price. So I'm just mocking the tool. I'm not actually making any tool calls. I want to check, I want to check what happens when the tool responds with any of these values and then how the LLM would interpret this. So there's something interesting happening here. These are the test results. Again, from lack of time and mistrust of internet, I will not run it now. But I'm trying to trick the LLM here a little bit and see what happens here. So when it got the price of $404, it made actually, let's look at this column here. Yeah. So when it got $404, it replied with the price of Microsoft is 404, and it worked well with most of the values, but then there's something interesting happening here. See, I apologize, but there seems to be an issue retrieving the current stock value. Anyone want to guess why this happened? It saw this 404 and it thought it's a HTTP error and not a stock price. Okay, so this is again the reason why we need to test the tool responses. And again, we can do it with evals like we did up until now. So to summarize evaluating agent, we need to really go back to the simple principles of breaking down the problem into smaller problems. Independently check each agent, make sure you evaluate the tool calls, and if the platform that you're using is using LLM as the agent orchestrator, then this is just another agent, right? Like you should be able to write evals to test that agent orchestrator is calling the correct or your expected tools or your expected blocks at the right time. So again, so now we have another step here is evaluating agents. We're using the same tools that we use up until now, right? We haven't introduced any new tool. We're using data sets, we're using evals. Maybe they're more complex, but the principles are the same. And so just to summarize this talk, I think the main takeaways are, one, make sure that you break down your complex tests into the smallest pieces possible. Focus on convergence focus on coverage just for the smaller units, and make sure that you only test the most critical paths of your system with evals, but don't try to test all the different branches of agents. And Again, a very, I think, known principle for software testing should apply here as well. The effort that you put into testing the smaller units is much better than the effort you put into testing with integration tests or complex tests. So make sure that you really focus on making sure that the smallest units are well tested and everything else would be fine beyond that. Yeah. Thank you. Looking forward for the rest of the day. I'm sure it's going to be great.